Hi, welcome to Raji's classroom. Today's topic is nuclear stability. Let's go to the topic. Hi, welcome to the topic of nuclear stability. The term is otherwise known as zone of stability or belt of stability, and this topic explains the relationship between NP ratio value and the nuclear stability. The difference between the number of neutrons and the number of protons is known as NP ratio, and the value of NP ratio indicates the nuclear stability. If the number of neutrons value is plotted against the number of proton values, means it is found that the NP ratio of the elements with stable nuclei lie within a region, and that region is known as zone of stability or belt of stability. And this is the picture which explains the relationship between NP ratio value and the stability of the nucleus. So in this picture we can see that whenever the number of neutrons value is always equal to number of protons, means the NP ratio is equal to 1. So it formed in the linear line. That means in the periodic table the elements with atomic number up to 20, which always have the NP ratio value is equal to 1. So the elements up to atomic number 20 is always found in this linear line. If you take the elements with atomic number greater than 20, means in that condition the elements maybe have higher number of neutrons or higher number of protons. So at that condition the NP ratio value may be increased or may be decreased. So whenever the NP ratio value is increased from 1 to 1.5, so at that condition the NP ratio value is found in the region indicated by the pink line, and this area is known as belt of stability. That means the elements with the atomic number up to 80 which have the NP ratio value is equal to 1.5. For example, if you take zirconium, its NP ratio is 1.25, and tin, it has its NP ratio as 1.4, and mercury with atomic number 80 and mass number 200 and its NP ratio is 1.5. So the elements with atomic number up to 80 which have the NP ratio as 1.5. So the elements with up to atomic number 80 is known as stable elements, or it is otherwise called as non-radioactive elements. So in the another condition, when the atomic number is increased, means maybe the number of neutrons increased or the number of protons increased. So in first condition, if the number of number of neutron is increased, means at that condition the value always falls above the zone of the stability belt. So in that condition the elements become unstable, so which become stable by emitting beta particles. It is nothing but, if you take carbon 14, its NP ratio is 1.33. So the nucleus is somewhat unstable and it emit one electron. That electron is called as beta particles. So by emitting beta particle, it becomes nitrogen 14, and the NP ratio of nitrogen 14 is 1. That means the elements become more stable 1. And in the second example, take sodium 23, its NP ratio is 1.18 and somewhat unstable, and by emitting one electron it's become magnesium 24 with NP ratio 1. That means become more stable nucleus. So whenever the number of neutron is higher, means its NP ratio is too high, it always found in the above region of stability belt, and the unstable nucleus becomes stable by emitting beta particles. If you take the second condition, that means if the elements have greater number of protons, means at that condition the NP ratio value is too small, so the big elements becomes unstable and it emits positron and become stable nucleus. For example, if you take carbon 11, its NP ratio is 0.83. That means the nucleus is unstable, and by emitting one positron, that means plus one E0 is called as positron particle, and emitting positron particle, it becomes stable boron nucleus, and the NP ratio of boron is 1.2. So the unstable carbon becomes stable boron. In the second condition, if you take nitrogen 13, NP ratio is 0.86. It indicates that the nucleus is unstable one, so it also emits one positron and becomes stable carbon nucleus with NP ratio 1.16. So in the periodic table, whenever the atomic number is increased greater than 84, the NP ratio value is equal or greater than 1.52, means that isotopes or elements are considered as radioactive elements. That means they are unstable elements, so undergo radioactivity. That means the radioactive elements undergo disintegration spontaneously and become stable elements. I believe that this video will give the relationship between the nuclear stability and NP ratio value. You must understand that relationship. Thank you for watching. We will see in the next video.